Good afternoon, everyone. Welcome to the session. Thanks for everyone who's joining us. Thanks, Taffy, for getting the session going. And yeah, let's get going, guys. Taffy, if you don't mind just stopping the screen, the video share, so I can take over on my end. Thank you so much. Great, guys. Welcome to Learning Space Winter School, where we are here to help you guys really make the most of your holidays so that you can prepare for the exams that are coming up, which are going to be very big exams. Essentially, you guys have got prelims coming up. I don't even want to say months, in a couple of weeks' time, essentially. And your prelims are probably the most difficult exams you're going to write this year. So I want you guys to pat yourselves on the back because the decision of being here is a very critical one, and it's really going to help you guys, right? So, as the learning space, we are here to help you guys really get your hands around that. We are going to go through some concepts this week. I think we're ending next week, Monday, where we're going to help you on certain topics on maths and physical science. This is a physical science session from 3 until 5 o'clock. We'll take a 1 hour break. Then there's another mathematics session run by Tabang from our team. He's also a phenomenal mathematics tutor and educator. And you guys will have that session there. If you check out TikTok, you'll see the schedule for all the lessons coming up. I think maybe I'll ask someone in the team just to share it in the chat as well. Okay, so key thing, guys, this is an interactive session. Someone did ask in the chat there, how do you turn your cameras and mics on? So because of this is a webinar format, there's a lot of people that join the session. We use a webinar instead of using just a normal meeting, just because the meetings are limited to the number of people who can join, and webinars give you more access to people. If you would like to turn your microphone on to ask a question live during our session, just put a hand up. With your hand up, we can then see who's got a hand up, and then I can allow you to unmute to ask your question live. Other ways to interact with our session, we do have a Q&A as well as a chat, right? So if you've never engaged the webinar before, the Q&A allows you to ask a question. I'll see the question, and then I'll decide whether it's a question that we will type and answer back to you, or if it's a question I'd like to answer live. But we will answer every question that comes our way, coming this way. The one thing I want to then encourage you guys is just giving you a little bit of guidance in terms of really good questions. So what I tend to then say is we will then we will answer questions that are of a very high quality. What do I mean by a very high quality question? So if you say, please repeat, that's not a very high quality question, right? Because sometimes I pause to look at the chat. Maybe it's 5 minutes after I was busy with a particular question. So if you just say, please repeat, I don't know what you're referring to. How I want you to post high quality comments or ask high quality questions to say, sir, in the second step of 1.3, I don't understand how you did X. So that is a very high quality question. It allows me to directly go back and solve your problem. And yes, those who are asking, we are recording the session, but I will encourage you to stay in the live session, because in the recorded session, you don't really get an opportunity to ask questions. Whereas when you're sitting in a live session, you can put a hand up, you can ask in the chat, and you can ask questions. And one very important thing on my end is I want lots and lots of interaction, right? So it doesn't help to just sit and passively try and learn. I want you to take this as an active learning experience. What do I mean by an active learning experience? Is engage whenever I ask for engagement. So you'll see at various times in our lesson, I will ask you guys questions, right? And I would expect answers from you. How you do that is go to the comments, right? Go to the chat. Don't use the Q&A when I ask you for that. Go to the chat. The Q&A is for a question that you have outside of what I'm doing. If I ask you a question, go into your chat. If you're on Zoom, if you're joining us on TikTok, go to the comment section on TikTok and then post your comment or your question there. For example, let's quickly try it all together. I'll say, in one word, how are you feeling about organic chemistry? So today is a physical science session. We're starting with organic chemistry. In one word, how are you feeling about organic chemistry? This is your chance to now go into the chat or in the comment section if you're on TikTok and post how you're feeling about organic chemistry. I'll give you guys 2 minutes. Quickly post how you're doing. Rabbit is uncomfortable. Azaria is good, excited, Balesa, comfortable in the middle about it, okay, passing, confused, don't like organic chemistry, very bad, excited, good. unsatisfied, bored, confused, middle, good, excited. Well, all I can say is superb, confused, good, uneasy, comfortable, confusing, in the middle. So Lord Molef has put a hand up, right? We haven't done any content, but I will allow you. So again, at this point, I want hands up to go for content-based questions only, right? So if you've got a question on the content we're covering as we're covering it, then you'll put a hand up. But thank you guys so much. Then this works really good. So you guys are getting the hang of it. The next thing I want you guys to try and do now is at various times after I ask you a question and you guys respond in the chat, I might ask you guys to do a little bit of a celebration or a little bit of a reaction. So this is where you're either going to use Zoom reactions or you're going to post an emoji in the chat, right? So in an emoji, how are you guys feeling? Either post a reaction or post an emoji in the chat. You can give me a fire emoji, dancing emoji, alien emoji. Let's get creative. I see the thumbs up. Thank you very much. Yeah, but let's get creative. Fantastic. You see, okay, cool. You guys are going to be an epic class. I'm going to enjoy today's session. All right. So now that we get the reactions out of the way, you guys understand how to engage and interact in this session. I'm super happy. Now, let's get started. I'm going to just share my screen shortly so that we can then look at the stuff together. All right. Give me 2 seconds to get that going. Okay. As far as I see, my screen should be sharing. I just need to pull up my chat and Q&A up separately so that I can still see your guys' comments and everything there. Give me 2 seconds just to set that up. Okay. Rabbit, I see you've got a hand up. Is it a content-based question? If it's not a content-based question, then I'm not going to go ahead and answer the question, but I will give you a chance to speak just now. Let me finish getting my things all together. Okay, so I'm going to allow you to talk, Rabetsu. You can unmute and ask your question if you'd like. Rabetsu, you had a hand up. If you'd like to ask your question, just quickly unmute and ask your question. I'll give you 5 seconds, and then if you don't do that, then I'm going to just continue on with the session so we don't lose time. Okay, I'm going to lower your hand and disable talking. And then again, guys, should you want to ask a question live as I'm going through the content, please do so. I am going to switch my video off just to save you guys some data, but I'll keep my screen share on and I'll put my video back on at the end of the session today. Awesome. If you guys are not following us on our social pages, please go to @thelearningspace.za on YouTube to watch video lessons, on TikTok to watch little awesome shorts on certain content pieces, and Instagram as well, right? We post a lot of awesome content there. So please do follow us if you're not following us. And we really would appreciate it. If you're in the session and there's a friend you know who would really do with help on organic chemistry, please forward this link to them so that they can join the session. That'll be very useful. Awesome. Last reminder, this is an interactive session. Please use your chat and Q&A for questions. Also use your reactions and emojis to participate. If you'd like to ask your question directly, raise a hand and you'll be given a chance to ask. We're going to jump straight into organic chemistry theory. So how the session is going to be structured, I'm going to spend about 20 to 30 minutes just going through theory, going through some notes, things that we need to sit and sort of take note of and look at and go through. And then I'm going to spend the last hour and a half going through actual past paper questions, step by step, showing you guys how to approach the question when you're asked a particular thing, how you go by answering it, essentially, right? And remember, ask your questions throughout the session. If something confuses you in that moment, ask the question in the moment. Don't wait and then end up forgetting the question, right? Awesome. So again, we're dealing with organic chemistry, right? Which is the chemistry of organic molecules, molecules with a carbon inside. And we're going to go through a whole bunch of understanding how these things go. Organic chemistry comes in 3 flavors. or three subsections of organic chemistry. So first one, we're looking at nomenclature or naming and drawing. Those are the kinds of questions where they'll give you a structure, ask you for the IUPAC name, or give you the IUPAC name and ask you to draw the structure or the condensed structure, etc., where they'll deal with isomers, that kind of thing. Then you get organic physical properties. The organic physical properties is where we're dealing with your boiling points, your vapor pressure, and all of those things there, and how intermolecular forces affect all of those things. And then the final chapter of organic chemistry is going to be organic reactions, where we're looking at how different organic molecules react and the different types of organic reactions. All right. Quickly report into the chat. Someone said the screen is not clear. Sometimes what does happen is if your internet connection is a bit slow, it does go blurry. I'm going to zoom in when I start. I haven't started going through it fully. I'm going to zoom into the parts that I'm talking about now in the notes. So just double check that your connection is fine. If you are using Wi-Fi, move closer to the router. If you're not using Wi-Fi, using 4G or 3G, please try move around wherever you are just to get a little bit of a better connection. What does help is if you do a speed test. So speed test, if you go to www.speedtest.net or just go to Google and type speed test and just make sure that your download speed is more than 10. Then you know you will have a decent experience, right? Okay. Tandek is asking if we are going to share the notes. So what we will do at the end of the session, I normally post all of my workings out and everything I do, my notes and the solutions and everything we wrote down in the session on our WhatsApp community. So I don't know, Taffy, if you've got the link for the WhatsApp community, but if you can post it there, then I will share those things in our WhatsApp community. All right. Then other one, screen is not clear. Just double check. Taffy, please check on your side if it's on my end or what, because my speed test is pretty good. So my connection should be fine on my end. Thanks. I see Vuyo's got a hand up. Vuyo, we allow people to talk for content-based questions. So because I haven't touched any content, I'm not going to answer any verbal questions until I've done covering content, right? If you do have another question, please post it in the Q&A. And then we normally use that, the chat to react. So license says, is this for term 3 or general introduction to it? So organic chemistry was covered in term 2, not term 3, right? But, it's a very big part of your final paper. So the topics we're going to be covering in our winter school, we're covering organic chemistry. We're going to cover electrostatics. We're going to cover the Doppler effect. We're going to cover electric circuits. Some of them are term 3 topics. Some of them are term 2 topics. And then we're just going to make sure we do a really good revision across the board of them, right? Okay. And then how do we get into the WhatsApp community? We will post a comment in the chat now where you can get the link. So I think Taffy is trying to get the link from Theo on our team, and then we'll post that link. So let's just get started with the content, and then we'll share that before the end of the lesson. What we'll also do, Taffy, maybe if you don't mind, for everyone who registered for the session, can we send an SMS out just with a link to the WhatsApp community? I think that could also just be easier. And then you'll get the link later on in the day. Cool, guys. So jumping into organic chemistry. So we're going to start by looking at now the structures behind this, right? So before we do that, we need to look at a few definitions of what things are. So you think we're dealing with things like homologous series, functional group, etc., right? So these are terms that you'll see as you write in your exam. They'll ask you what homologous series or what is the functional group, right? So homologous series think of it as the family name for organic structures. So you'll have alkanes, alkenes, alkynes, but you don't necessarily cover alkynes in the CAP syllabus now anymore. Haloalkanes, alcohols, aldehydes, ketones, etc. It's a family name for that organic compound. Now, then you'll deal with things like the functional group, right? So the functional group is a characteristic of that family that makes it unique. So think, for example, people often tell me that people in my family have big or weirdly shaped heads. So as Mr. Rangaka, who's your presenter today, my family name or my homologous series would be the Rangakas, and our functional group will be a big or funny shaped head. So functional groups, for example, you've got the CC single bond. That's the redeeming, or not the redeeming, but the unique feature that you can identify the family of alkanes. Alkenes, you get this double bond. It could be, ooh, the alkene family have got weird, big ears. The alkyne family's got long legs. The haloalkanes are normally very fast runners, but it's a physical feature that you can look at to identify what family this thing comes from, right? And the suffix is simply how you name it, and we'll get down to that in a second. I want to quickly just go through some definitions with you guys. Guys, please don't sleep on definitions. Definitions are so important because you get a lot of marks for these definitions and they're quite easy to remember, right? So let's go through some quick definitions. So in our definitions, we're looking at the hydrocarbon. Hydrocarbon basically is, or they are organic compounds that consist of hydrogen and carbon only. So you're looking at alkanes, alkenes, alkynes. Those are hydrocarbons, right? Alcohols, carboxylic acids, etc., are not hydrocarbons because they've got more than just hydrogen and carbon, right? Then going into your homologous series, it's a series of organic compounds that can be described by the same general formula or in which, apologies for that. Let me just quickly put my iPad on DND. Sorry about that. So it's a series of organic compounds that can be described by the same general formula or in which one member differs from the next with just a CH2 group, right? That's a homologous series. Like I mentioned to you guys, the homologous series, think of it as a family of hydrocarbons. Just 2 seconds, Taffy, if you're there. I think my screen is frozen a bit. Do I need to restart my screen share? Okay, let me quickly restart my screen share. Apologies, I had a phone call come in and it interrupted my iPad. Okay, let me just do this. Okay, I think that should be better now. Okay. Guys, just confirm that you can still see my screen share. Is it back where it should be showing you definitions on my screen? Just give me a thumbs up, or any kind of emoji to confirm you can still see my screen. Perfect. Thank you so much. All right. So again, saturated compounds are compounds in which there are no multiple bonds between the carbon atoms in the hydrocarbon chains. So saturated compounds where you've only got single bonds, there's no double bonds, I can't undergo an addition reaction. That's what we mean by saturated compound. An unsaturated compound are compounds with one or more multiple bonds between the C atoms in their hydrocarbon chains, meaning you've got a double bond or a triple bond or multiple double bonds. But basically, it's any hydrocarbon that can undergo an addition reaction, which will be an unsaturated compound. And then finally, a functional group. Functional group is a bond or an atom or a group of atoms that determine the physical and chemical properties of a group of organic compounds. So functional group there, we're talking about that feature, right? The big Rangaka heads. That's a feature that tells you which homologous series something would belong to. Right. Now let's quickly go through all our homologous series so you guys can get to know them, right? And then we're gonna go through how you actually name things when you're dealing with IUPAC naming. So homologous series, we're looking at alkanes. So the structure of alkanes is going to look like this, right? It's the functional group, C, single bond C. So essentially there, you only have C, H, and C, C single bonds everywhere else. Alkanes end in ane. So the suffix is how you name it, right? Ane. I'll give you a bit of a hint. So there's I'll show you now, this meth, eth, prop, bute, etc. That tells you the number of carbons you're dealing with, and then the suffix tells you how to end the name, right? So if you had one carbon, that's going to be methane. If you had two carbons, ethane. If you had three carbons, propane. Four carbons, butane, etc. So it ends in the ane like that. That's an alkane. And then the general formula for alkanes is going to be CnH2n plus 2. So essentially, however many carbons you have, the hydrogens will be double plus 2. If I've got 4 carbons, my hydrogens should be 10. Double 4 is 8, plus 2 is 10. So C4H10, that's an alkane, right? C3H8, that's an alkane because C is 3, hydrogen is going to be double plus 2. Double 3 is 6, plus 2 is 8. So that's what the general formula normally refers to in that case there. And then we're dealing with the primary force between the molecules or the primary intermolecular forces. Please note that it says primary because some molecules like alcohols, like carboxylic acids, like esters, will have different types of intermolecular forces that they can utilize. So the primary one is the main one that is known about that particular molecule. So we're dealing with London forces. London forces are your induced dipole. So any non-polar substances, when interacting together, we usually have London forces. It's the weakest of the forces that we engage with when thinking about this. All right. Those are your alkanes. Alkenes are going to be similar to alkanes, except that your alkenes will have a double bond between your carbons. So your functional group will be this carbon-carbon double bond, right? Sorry, that is just a mistake in the writing. It's a double, not a triple bond, all right? It's a carbon-carbon double bond. And then they end in ene. So the alkenes. So you're looking at methene, ethene, propene, butene, pentene. Those are your alkenes. And then your general formula is CnH2n. So however many carbons you have, you've got double hydrogens. C3H6, alkene. C4H8, alkene. C5 H10, alkene, right? And then those will also have London forces in them, though they might be slightly stronger than the ones in the alkenes because double bonds require more energy to break them. But they will still be London forces essentially. Cool. And then I'm going to skip through alkynes. It's not tested anymore, right? And then let's go into our haloalkanes. So haloalkanes are simply your alkanes with a halogen, right? So you'll see that C with an X. X normally represents halogen. Your halogens are anything in group 7, your iodine, chlorine, fluorine, that whole line of atoms or elements in group 7. So you're dealing with a halogen atom bonded to a saturated C atom, right? And then your haloalkanes will still end in ane because it's an alkane. It just has the beginning of chloro, butane or fluorobutane or iodobutane. The key thing is that you're dealing there with something that's bonded to it almost as a group. Then we're dealing with alcohols, right? So our alcohols is going to be that homologous series, that particular family. How do we identify the family of alcohols? You have this OH connected to one of the carbons, right? And the OH could be connected to a carbon at the end, in the middle, or even one that's opposite another methyl group. So in this particular case here, your hydroxyl group bonded to a saturated carbon atom is the functional group for alcohols. Alcohols end in -ol. So ethanol, butanol, propanol, methanol, you're dealing with alcohols. And then there's no general formula that you need to know, but what you need to look at there is you need to look at the type of intermolecular force, and you're dealing with hydrogen bonds. Why is it a hydrogen bond? Because hydrogen bonds will exist when you've got hydrogen bonded to oxygen, nitrogen, or fluorine, right? Then that will be able to bond with an H bond with something else that has, let's say, a similar structure. Next up, aldehydes. Aldehydes have this double bond O at the end, right? And because at the end there, we call that our formal group, where you got double bond O at the end of your chain. Aldehydes end in -al, so ethanol, propanol, butanol, then you're dealing with an aldehyde. Tamara, I do see your hand. Let me quickly finish this line. And your aldehydes are going to have intermolecular forces of dipole-dipole. It's not hydrogen bonding because there's no hydrogen bonded directly to that oxygen. So it'll just be dipole-dipole. Tamara, your hand has gone down. I can't allow you to speak if I don't see the hand. Okay, I'm going to just continue. Awesome. Just to make sure, again, let me pause and answer some questions in the chat. Will we get time to take all of these down? This is from Lyson. So I'm going to share these notes, Lyson, at the end of the session with everyone in our WhatsApp community. So we'll share the link for the WhatsApp community, and then we'll even SMS you the link for the WhatsApp community, and then we'll share the notes with everyone. Um, Tips on how to memorize them. Sure. I don't have brilliant tips on how to memorize them. There's an awesome video I saw a few weeks ago for how to memorize organic physical structures. And I'm going to share that video with you guys later on. For these ones, if anyone has an epic way for us to remember them, please share it. I'll try find one and share it, but it's just the key thing is just memorize them. Alkanes, alkynes, alkenes, it's just carbons. Your haloalkanes is going to just be an alkane with a halogen attached to it. The only ones that become a little bit difficult are alcohols, aldehydes, ketones, and carboxylic acids, where alcohols for me only have the OH. Carboxylic acids will have an extra O. Esters will have the O in the middle. The only memorization technique I can give you there, especially for aldehydes and ketones, because they're very similar, is that aldehydes have the O at the end. Ketones, just like the word, have the O in the middle. So that's how I remember the difference between aldehydes and ketones, because those two are very similar. So the O for ketones is in the middle of the word. That's how I remember. Then aldehydes will be right at the end. Um, Someone says there's a song to memorize the methane, ethane, propane till decane. Hey, Lyson, if you want to sing the song for us, I'll let you unmute if you're keen. Dando says use cue cards. Hope says triple A HAKEAC. I'll unmute if you guys want to do that. License says no. Okay. Tapelo says you can abbreviate them. I was very keen to hear the song. The song would have been fun. Okay, cool. Awesome, guys. Let's jump right ahead. So ketones, like I said, very much similar to aldehydes, except that the double bond O is in the middle, not at the end. So we call that our carbonyl group bonded to two carbons there. Ketones end in on, right, or anon. So where the aldehydes was propanol, ketones are propanon. That's how it ends. Same intermolecular forces because they have this a very similar functional group. It's a double bond O. So you have dipole forces there. Okay, carboxylic acids, we're nearly done. Look almost like alcohols. It looks like if an aldehyde and an alcohol had a baby, you get a carboxylic acid, right? Where you get the double bond O and the OH on the end. We call this our carboxyl group. And then carboxylic acids end in enoic acid. So ethanoic acid, methanoic acid, etc. And then those will have hydrogen bonds. Reason being, again, we've got that hydrogen bonded to that oxygen, right? Which is important. Finally, then we're dealing with our esters. When looking through our esters are going to basically come in two parts. There'll be one part to the left that has a double bond O and one part to the right that doesn't have a double bond O with that oxygen in between joining them. Esters are formed by reacting alcohols and carboxylic acids, and then we call that esterification, and that comes together, right? Then our esters end in a noate, but it's got two parts, right? So you'll have like ethyl propanoate or methyl butanoate. So it's got two parts. The part without the O8 in the name, the part with the O8 in the name is the side that's got the O. So whichever side does have the double bond O is going to come from the carboxylic acid. And the side without the double bond O is going to have the YL name. So ethyl methanoate is going to basically be one of the names you can name esters. And then when dealing with esters, we got dipole forces, and reason being we don't have that H bonded with the O. If we had the H bonded with the O, we would then have our hydrogen bonding, right? Okay. Awesome. That's just a little quick one. Let's quickly go through IUPAC naming and then we can actually do some problems together, right? Before I move too far, please, I'm going to pause for questions now. Give me a thumbs up if you guys are still with me or any kind of emoji in the chat so that I know I can move on. If you're still unsure, please post your question in the Q&A or the chat right now, or you can put up a hand now to answer to ask your question live. Thanks, Tsofatso. And Salilo, and Sabunile, and Naledi. Okay, thanks, Omila. Okay, Debuch is good. Kamchel is good. Tsofatso's got a hand up. Okay, I'm going to allow you to unmute Tsofatso. So just unmute and then you can ask your question live.
Sir.
Yes, how can I help?
Okay, I was just making sure if you can hear me. Okay, I missed the part where you said just before IUPAC naming.
So before IUPAC naming, I was just going through all our homologous series, listing all of them, and then I finished off with esters.
Oh,
Um,
okay.
yeah, if you were disconnected, we will have a recorded version of this lesson that we're going to post on our YouTube in the next 2 days. You can watch it there, and then I will also share the notes I'm taking in our WhatsApp community. We'll send you a link. If you registered for the session, we're going to send you a link to the WhatsApp community, and then normally we'll share our resources there as well. So far, so you sorted.
Thank you. Yes,
Okay, it's a
thank
pleasure.
you.
Thanks. Okay, licenses, do we have to register every day? So you registered once for the our winter school program. That is fine. Then what will happen? We will just send you guys links as reminders for the webinar. So to join the webinar, you must enter just so that we can make sure that it's someone that had registered for our winter school program. So that Zoom registration you do every day, but the registration on our website, that doesn't happen every day. That you just do once and you should be fine. We'll send you the links and everything from there. Okay. And then Letabo says the way in which the structure is drawn in the alkene, in the diagonal bond, do we have to draw it in that manner for exams? Okay, I think what you're referring to is this here, Letabo, if I'm correct, right? So this there. So this is how we drew the functional group. So those diagonal bonds, no, you don't have to. Just that when you think back to grade 11, you guys did your VSEPR. So in the VSEPR, or your valence shell electron repulsion theory, right? How molecular structures are put. Generally, this is what would happen. You don't have to put it that way. You could draw it literally with just CC and then just draw them up like that. You can draw them like that. You wouldn't get marked down for it. It's just that this is it's more correct, but you're not going to get more marks for it. I hope that helps. Um, and then Nikita's general formula for the other groups. So Nikita, for the general formulas or formulae that were given, the ones that are examinable are these ones here, right? You don't generally get general formulae for the other groups. So as long as your alkanes and alkenes, you've got those ones down, then you are sorted. The other ones are not examinable. Okay. And then Yusuf says, is there a fee to be paid for these classes? Yusuf, you're in the session right now and you didn't pay for the session. So no, there isn't a fee to be paid for the sessions. So periodically leading up to exams, we do these kinds of webinars to help learners engage. And then we've got different people that we do engage with. So as the learning space, we do have other clients that we engage, and we've got schools that are supported that are sponsored by certain entities, right? So for that attendance, then that is sponsored. And then if you're in one of the schools that are operating with us, we'll give you data and all of that to join the sessions. But attendance is not paid for. It's just that the data is paid for by sponsors. If your school is one of the sponsored schools that we work with. Okay. Then I've got some Q&A questions as well. So Gauta says, what is a suffix for esters? That's a great question. So coming back to esters, right? It's a no-wait, but in actual fact, you've got two suffixes, right, for esters. Let me quickly just amend this. The first one is a YL. The second one is the no-wait. So depending on where you started. So let's say, for example, I had this ester. So C dash C, O dash C dash C dash C. And this one has the double bond O. I'm not going to put the other H's and everything else in, right? So what we know is that the side with the double bond O, let me quickly highlight. So the side with the double bond O, that gets the NO8, right? And then the side without the double bond O gets the YL. then we need to think about, okay, cool. On the left-hand side, I've got 2 carbons. Right-hand side, I've got 3 carbons. The YL is the blue one. So that'll be meth F. So it'll be ethyl, right? And then the side of the double bond O gets the anoate one. And I've got 3 carbons, proper, sorry, proper, no weight. So your suffix for esters is going to be 2. Because there's always 2 words. First one is going to be YL. Second one is going to be anoate. So ethyl propanoate, for example, is this ester that we're dealing with here. That's how those questions that are answered live. And then Sanabelo says, but sir, last March they asked for general formula of carboxylic acid. March, Sanabelo, is this particularly was this a class test or what kind of exam was it, right? Because if you look, let me try and get the exam guidelines for us. And if I made a mistake, I definitely will correct it, right? And then Lord Maleficent says, are you going to explain boiling points with Van der Waals forces with organic molecules? You're definitely going to do organic physical properties as well, Lord Maleficent. All right. For KZN March 2025, Sanabello. KZN March 2025, is this like the supplementary paper? I'll try find the paper and I'll look at it and I'll check the exam guidelines as well, right? And if it has changed, I'll get that together and I'll send it through with the notes with you. But I definitely will have a look at that. Okay, cool. Okay. And then Pumeza says, is it LY or YL for the alcohol in esters? It's YL. So ethyl, methyl, propyl, etc. Not LY. So not ethly or proply. It's ethyl, YL. Okay. Okay. And then someone asking, are there any grade 11 winter classes? And unfortunately, Gitabe, no, we don't have grade 11 winter classes. We will be doing grade 11 online classes as soon as term 3 starts. So from the beginning of August, we're going to have grade 11 classes. And then we'll share links on our social pages for those that want to join, right? And then finally, can you explain the types of alcohols? If you have, please, can you go over it again? No worries, I definitely will do that before we get started with the question, right? So when going through the types of alcohols, I'm gonna do the naming and then we'll do the types of alcohols as soon as I'm done with that. Maybe let me quickly do that for you guys, right? With types of alcohols, let me just add a page. Okay, so when dealing with types of alcohols, right, we've got 3 types of alcohols. We've got primary, secondary, and tertiary. I'll quickly draw them out for you. Okay, this is again all for alcohols, right? So a primary alcohol is an alcohol where your hydroxyl group is connected to a carbon that is connected to one other carbon. In short, a primary alcohol has the hydroxyl group at the end of the chain, right? So you basically have your carbon, carbon, and your OH is right at the end. So the carbon connected to the OH is connected to only one other carbon. Secondary alcohols, the carbon with the hydroxyl group is connected to 2 other carbons, meaning your hydroxyl group, your OH, is somewhere in the middle of your chain. So basically, that carbon with the OH has 2 carbons connected to it, right? So if you think about the whole primary, secondary, tertiary, primary alcohol, that carbon has 1 carbon connected to it. Secondary has 2 carbons connected to it. And then you guys can then guess tertiary alcohols, the OH, the hydroxyl group, is on the carbon that is connected to 3 other carbons. So you'll then have a carbon, a carbon, a carbon, a carbon, and your OH is going to be over there. So you can see there that that carbon is connected to 1, 2, three carbons. And that's how you distinguish between your three types of alcohols: primary, secondary, and tertiary alcohols, right? Hope that makes sense. Will you be able to do combustion and esterification? We are going to do organic reactions as well. So yeah, hang tight. We definitely will do that. Cool. Let me just make sure I've got all my questions sorted. One more question. Can you please repeat the part about naming an ester? 100%. So when naming esters, remember, we have two parts to an ester, right? Esters are formed by reacting an alcohol with a carboxylic acid. So the part with the alcohol gets the YL. So if you had propanol, you'd have propyl or propyl, however you pronounce it, as long as you spell it right. And then let's say we had the carboxylic acid was ethanoic acid. So then we'll have propyl ethanoate. So the alcohol part gets the YL, the carboxylic part gets the anoate. Cool. Nonhlanhla says, how do you differentiate between a functional group and a functional isomer? So we're going to talk about isomers just now, Nonhlanhla. So maybe that will answer your question when I get to that part. A functional group, like I mentioned to you guys now, the definition, we did have it there. A functional group is a bond or an atom or a group of atoms that determines the physical and chemical properties of a group of organic compounds. Whereas isomers is something different. Isomers are different molecules that have the same molecular formula, but different structural formulas. So functional group, think about it. Remember what I said earlier on. It's the physical feature about an organic molecule that gives it its properties and also aligns it with its family. So like I said, if my homologous series is Rangaka, which is my surname, my functional group will be a big head. The Rangakas have got big heads apparently. So my functional group is a big head. Isomers are something very different. So we'll touch on isomers just now. Okay, so IUPAC naming, let's quickly go through it speedily. So the IUPAC name combines a prefix, a root, and a suffix. Very important that we note those things there. Prefix, root, and suffix. Okay, the prefix tells us about the existence and positions of halogens and alkyl substitutes. So alkyl substituents. These are what we call our branches, right? The methyl, ethyl branches. So for example, 2,3-dibromo, 2-dichloro, 3-methyl. Those are all your substituents, your alkyl substituents. Note that these are listed alphabetically, very important, ignoring the di, tri, tetra. Okay, count from the side of the longest chain that makes the numbers for the functional group as low as possible first, then prioritize counting from the side that makes the number in the prefix as low as possible. Remember to be consistent and always count from the same side that you when you've chosen one. So that's the substituents, that's your prefix. So your dibromo, dichloro, methyl, ethyl, all of those things there, those are your prefixes. Then the root tells us about the longest chain, right? So the root tells us what is my longest chain. So my longest chain of carbons. So we're gonna basically look at this. So we'll either have 1, 2, 3, 4, 5, 6, 7. I think you guys go up to 8, where 1 is eth, sorry, 1 is meth, 2 is eth, so as in like methyl, ethyl, 3 is prop, as in propyl, or propane, 4 is bute, like butane, 5 is pent, like pentane, 6 is hex, like hexane, 7 is hept, like heptane, 8 is oct, like octane, right? Those are what we call the prefixes that will tell you about the root of the name of your IUPAC name. So that root tells us about the longest chain, right? In that case, the example, meth, eth, prop, bute, etc. So if your chain has got 5 carbons, then you know you're going to have the root of pent. Then finally, you've got your suffix, right? The suffix tells you about the functional group and its position if necessary. For example, butan 2-3, 2,3-diol says I've got 2 hydroxyl groups, one at my second carbon and another one at my third carbon, right? And I've got 4 carbons in total because that's what the bute tells me. So bute is 4 carbons. right? Diol means I've got two OH, right? Two hydroxyl groups, one at number 2 and one at number 3. That's how that basically means. So count from the side that makes the numbers that indicate the position of the functional group as low as possible. Okay. We'll do a worked example quickly together of this here. So identify the longest chain. That's the first thing. So when you look at this here, some people, and if you are fast enough, I want you to post the number of carbons in the longest chain in the chat. Okay, have a quick look at this thing and tell me how many carbons in my longest chain. And then I'll do it step by step if you want to have me do it with you guys. So some people would say, oh, here's carbon, carbon, carbon. That's a chain of carbons. 3, right? Some people will say, actually, no, I've got this chain here, which has got 1, 2, 3, 4, 5, 6, 7 carbons, right? Some people say, no, 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 that isn't the longest one. The longest one is this one, which has got 1, 2, 3, 4, 5, 6, which is not longer than 7, right? And then you can just do, maybe you'll go 1, 2, 3, 4, sorry, not meant to happen. 1, 2, 3, 4, 5, 6, 7. That's also 7 carbons. Or the correct answer is 1, 2, 3, 4, 5, 6, 7, 8. So if you've got 8 carbons in your longest chain, give yourselves a round of applause, give yourselves some kind of fire emoji, dancing emoji in the chat just to celebrate, right? And then you can see in that case there, that's what we're dealing with. Before I note the questions in the Q&A, let me just finish my thoughts on this here. So the longest unbroken chain of carbon atoms is 8, right? So oct will be our root in this case here. Then the next thing is that we have to number our carbons. And remember, we have to number them from our carbon closest to the functional group. In this case here, we're dealing with an alkene, right? A diene essentially, because I've actually got 2 double bonds. So this is what we call a diene, but it's an alkene. So we have to number these from the carbon closest to my functional group. So I'm not going to start here because that functional group is very far from there. I have to start from there. So as I number, I'm going to say this is carbon number 1, 2, 3. Sorry, let me make this a little bit smaller. Carbon number 1, 2, 3, 4, 5, 6, 7, 8, right? And that's now, I've looked at that. That's my number of carbons in the chain. And I've got 2 double bonds, which are for my alkenes. The next thing I need to do when I need to then look at this and name it, I need to find all of my side chains. So let's highlight our side chains. All right, so side chain number 1, I've got this methyl side chain here on carbon number 3. I've got another methyl here on carbon number 6. So this will be a dimethyl, a 3,6 dimethyl. I also have a bromo on carbon number 6 and another bromo on carbon number 5. So this will also be a dibromo, a 5,6 dibromo. And now I've covered basically everything else there. So when we do this, we will think about our root. Our suffix is going to be all the side chains, right? Our root is going to be our 8 carbons, and then our suffix is going to be the functional group, which we have to then identify. What is our functional group? We see this double bond carbon here, double bond carbon. That tells you it's an alkene, but because I've got 2 of them, we normally refer to that as a diene, just like that. Awesome. We'll write the final thing together just now. Let me just pause for some questions in the chat. Okay. License says, sir, isn't there different shapes to identify the longest carbon chain? So isn't there like different shapes? License, I'm not sure about your question. But you can put a hand up and then I'll let you speak and ask your question live just to get a better understanding of it, right? And then Lyson also asks, why do we use die? So die, it's because we've got 2 of them, right? So when you've got more than one of a functional group or more than one of a side chain, we've got numbers that we then use, right? I don't know if they're Greek or Latin or whatever. I'm not good at that stuff there. But so if you've got 1 times something, we refer to it as mono, but we don't normally sort of deal with mono. So if there's 1 of something, it just becomes an alkene. We don't worry about anything else. It's just an ene. But when we've got 2 of something, right, that's going to be di. So for example, diene. if you've got two alkenes in that particular space. Or you can also have diol. So if you've got an alcohol with two OHs in it, that's a diol, right? If you've got three of something, that's tri, right? So tri is when you got three, so you can have trimethyl or whatever. So let's say, for example, trimethyl, if I had three methyl groups, and if I've got four of something, we refer to that as tetra, right? Example, tetrachloro. So for example, if you've got, let me draw a carbon with four chlorines. So that's an organic molecule with a single carbon. So one carbon is going to be methane, and then the four chlorines are going to be side chains. So we're going to have um, tetrachloromethane, essentially. That's how you'd name that. So tetrachloromethane is going to be four of my chlorine side chains on a methane molecule. Hope that makes sense there to you guys. Let me quickly keep going through this here. Okay, that one has already been answered. Um, would you say it belongs to the haloalkanes? So this one here would more be a haloalkene essentially, because it's an alkene, right? But we don't normally refer to haloalkenes as its own functional group, but it is a haloalkene, right? Um, and then someone says, do we start with the branches or the halogens? So you start in alphabetical order, right? And then you'll see, I'll finish that off just now as well. And then Diso says, when naming compounds and you have halogens and side chains, you start counting the side with the halogens or the side with the side chains. You start naming from the side closest to your functional group. So in this case here, our functional group is going to be the double bond carbon. So we name from there essentially. If we didn't have the double bond carbons, we would just go to the opposite end because that's the closest side to our side chains, which in that case would be our functional group, which would be it'll be a haloalkene. So the side closest to your bromine would be your haloalkene. That's what you would do there. Cool. Zach says, so sorry if you already repeated it, but do we start numbering the carbon chain from there because of the double bonds? 100%. That's why we do that, Zach. Gauta says, don't we say ethene, propene, etc., depending on the number of functional groups? Gauta, no. So the ethene, methane, propene is the number of carbons. The ene at the end tells you that I've got a double bond carbon. If I had two double bond carbons, we would then say prop diene. So the di says I've got two of my enes. If I had three double bonds, it would be tri-ene. I've got three of my enes essentially. I hope that makes sense there. And then Nonstanza as well says, do we name them alphabetically? Yes, when we put the groups in, we put them alphabetically, ignoring the di, tri, whatever, just the name, main thing. But you'll see, I'll give you the final answer just now. Okay, thank you for all those questions there. Let me quickly double check the chat for anything, and then we'll keep it going. Apologies, guys. I must check that we are live on TikTok. So Taffy, if we are live on TikTok, I can't see the questions that are there. So I don't know if you're able to send me TikTok questions, or I'll try join the live on my phone just so I can see them. Let me quickly do that and see if we are live on TikTok. We are live on TikTok. Okay. Apologies to my TikTok gang if I've been ignoring your questions. I hadn't seen them, but I've got it open on my phone now. So I should see the questions that come through on TikTok. Okay. Okay. All right. Just going through more questions there. Doesn't mean we can't write it like this, name to in. Zipo, I'm not fully sure exactly the name to in, but maybe I'll come back to it just now. Tsogofato's got a hand up. Let me ask Tsogofato to talk and maybe ask her a question or his question. Okay, so Fatuteka, you had a hand up and I'm gonna allow you to talk. Okay, hand is down. Maybe your question was answered. Okay. Cool. And then Pakiso just put an answer there. I'll come back to that. Nikita says, will we go through tests for saturation such as bromine and permanganate tests? Not in the question that I've got, but if we're done, I'll try and see if we can go through those as well. But that's a good note there, Nikita. I'll try and make a note on my end. Saturation tests. Right? Okay, cool. Can we go over more IUPAC examples, please? This is from License. We're going to do a full past paper question license, so you'll get lots of examples to do that. And then Yeleti gave us the answer that she thinks would be the right one. And then the answers are going to be there. So we did all of the steps in between, right? So when you put it all together, this is what you should get. Your 5,6-dibromo, keep in mind, right? Bromo comes before methyl, B before M. So then you get your 5,6-dibromo because we've got bromine on the 5th carbon and bromine on the 6th carbon. Then you're also going to have your methyl on the 3rd and the 6th carbon. So you'll have your 5,6-dibromo, 3,6-dimethyl, octa 1-3 diene. And that diene is because I've got two double bonds on the 1st carbon and on the 3rd carbon. Okay, so well done to all those that did get that one correct. The only thing I'd say to LT Shabangu, just double check. You said 2 for octadiene. You always opt for the smallest number. I know the 2nd carbon does have a double bond and the 4th carbon has got a double bond. That's true, but always opt for the smallest possible number. So instead of picking the 2, pick the 1. Instead of picking the 4, pick the 3. It's going to be 1, 3 diene. Awesome, guys. Hope that made lots of sense to you guys there. Let's quickly jump into a past paper question that we can then do together. Or before that, sorry, isomers. There's a lot of theory when it comes to this, and then we'll quickly touch on that past paper question. So let's quickly go through isomers. So structural isomers, right? It's a group name for everything there. So structural isomers have the same molecular formula, but different structural formula, and thus a different IUPAC name. There are 3 types of structural isomers: chain isomers, positional isomers, and functional isomers. Chain isomers have a different longest chain length, but the same structural formula. So you could have like octane versus methyl heptane. Those are 2 chain isomers. Positional isomers have the same molecular formula, but a side chain halogen or functional group is on a different part of the parent chain. So your methyl heptane could be a 2-methyl heptane versus a 3-methyl heptane. I've just moved my side chain along. Functional isomers have the same molecular formula, but a different functional group, right? And are thus part of different homologous series entirely. Only certain homologous series can form functional isomers of each other: carboxylic acids and esters, ketones and aldehydes. So essentially, let me just put this together here. So carboxylic acids and esters can form functional isomers, and then ketones and aldehydes can form functional isomers. Those are the 2 ones to note there, all right? And then Dennis asking if dienes are under caps. Not necessarily, Dennis, but I've been noticing for the last 2 years, the non-routine problems in caps are getting trickier, right? So I want to just equip you guys as best as possible. And also, some people in this session do go to IAB schools. And so I have to cover all the bases that we need to be able to cover. So dienes, not necessarily under caps, but I want to have everyone as prepared as possible. If they can give you a non-routine problem and assume that maybe you are able to answer it in that particular way. Cool. So let's jump into our first full question, right? And the question is going to look as follows. So it says study the table below and answer the questions that follow, right? So we're given 5 different molecules labeled A all the way to E. define the term unsaturated hydrocarbon. So that's something that you guys need to do quickly. Quickly post your answers in the chat. How would you define an unsaturated hydrocarbon? We went through this in the beginning of our session. Define the term unsaturated hydrocarbon. Let me make it bigger so you guys can see it. Lita says, which year did you take the question from? I'll tell you at the end of the lesson, Lita. Thanks, Hauta, for your answer. Thanks, Kabelo and Naledi for your answers, as well as Yusuf as well, and Azaria. Okay, sorry, let me quickly copy this out. So an unsaturated hydrocarbon are compounds with one or more multiple bonds between the C atoms in the hydrocarbon chain, right? So I quickly put that answer down. With one or more, right? Multiple bonds. Between the carbon atoms in the hydrocarbon chain. Okay, so compounds with one or more multiple bonds between the carbon atoms in the chain. That is what we're dealing with there, right? Then 2.2.1 says, write down the letter that represents an unsaturated hydrocarbon. So what I want you guys to do is post what you think the answer is in the chat, right? Put down the letter of the letter that represents an unsaturated hydrocarbon. Quickly look at them between A, B, C, D, or E. Just put that in the chat. Thanks, Lita. Thanks, LT. Thanks, Houten Lady. Balenhle, Bonolo, Nyeleti. Thank you for all your answers there. Okay. In the chat, Lerato says, why are we saying one or more since a carbon with one bond is saturated? So, Lerato, I said one or more multiple bond, right? So if it's got one multiple bond, a multiple bond is a double or a triple bond. So that's what I mean by that. Okay. Awesome. Thank you everyone for dropping their answers there. The correct answer is going to be D, right? D will be our correct answer. Let's quickly put that down and look at why. So when you look at D, you got CH3, CH2 times 4, CH2. So how we can tell is the CH2 at the end, because that means what that looks like. I'm going to have C. Apologies, let me fix that there. It means I'm going to have a carbon and CH2 like that, right? And then this has got to connect with something before. And to make sure that I've got enough bonds around all my carbons, remember, I've got to have 4 bonds around all of my carbons. If I've got a CH2 at the end, it means I need to have a double bond before that. And that double bond will ensure that I've got 4 bonds around it, because if I look at this carbon here, I've got 1, 2, 3, 4, then I'm covered. This carbon here, I've got 1, 2, 3, 4, then I am covered. That's how I know that that is going to be my unsaturated molecule D. Hope that makes sense for you guys. Let's jump on to the next question. right? So next question there. Oh, before we go on, sorry, I keep forgetting. If you got that right, give yourself an awesome reaction in the chat. Fire emoji, dancing emoji, get creative if you want to, right? If you didn't get it right, but you see where you went wrong, that's also cause for celebration. So give yourself some celebrations in the chat. That's going to be very important. Okay. Let me check my TikTok gang. TikTok gang is not as interactive as everyone else. So if you are joining us on TikTok, please as we ask questions, post your answers in the chat and let's make it interactive. That's the best way to learn, right? Thanks you for anyone who's following us on TikTok at the Learning Space ZA. You'll find some really awesome content there. Let's jump on to 2.2.2. They want the IUPAC name of compound A, right? So compound A is this one here. So let's go look at how we can do that. So first thing I'm going to ask you guys is, what is my longest carbon chain for 2,4 for compound A? Post that in the chat. Let's see what you guys think. What is my longest carbon chain for compound A? I'm getting fives, I'm getting sixes, getting some more fives, but a lot of sixes. Okay, and the correct answer is six, right? So we're dealing with 1, 2, 3, 4, 5, 6, or you could have just gone from there, have gone straight down to six. It doesn't matter whether you go down or right at that last one. As long as you've got six carbons in your chain, that is going to be your longest chain, right? So that's going to be the root of everything. So we're dealing with six carbons. That's going to give us hexane, right? So I'm going to make a note there. So 6 times carbon is hex. Cool. Now that we've identified that, I'm going to try and then make sure we can find all of our side chains, right? So side chains will exist. Let's choose a different color to highlight. So I've got a side chain here. I've got a side chain there. So now I can number my carbons from the one closest to my functional group. And in this case, it's an alkane. So my functional group will be any of my side chains. I can't start numbering at the top because that means my first side chain comes at carbon 3. Numbering at the bottom means my first side chain comes at carbon 2. Always pick the lower number, right? So when picking the lower number, I'll then number these carbons as carbon 1, 2, 3, 4, 5, and 6. And now I know I've got two methyl groups at carbon 2 and carbon 4, right? So now I've got my prefix. My prefix is going to be all the side chains. I've got dimethyl, so 2, 4 dimethyl. My root is 6 carbons, that's hex. What is my suffix? What am I dealing with here? What's the homologous series? It's an alkane. So hexane. So 2, 4 dimethyl. Hexane is my answer. Let's quickly put that down in our answers. IUPAC name of compound A will be 2, 4 dimethyl hexane. All right, cool. Well done to everyone who's got the right answer in the chat. Give yourselves a big round of applause. Awesome little celebrations in there. Let me have a quick look at the chat, the Q&A, to answer any questions that are there. Okay, awesome there. Excuse me. So which homologous series falls under unsaturated compounds? So unsaturated compounds, we're dealing with alkenes and alkynes. So from a CAPS perspective, you're dealing with alkyne, right? And then license says why methyl. So remember, when you have a side chain, if there's only one carbon in your side chain, that's methyl. If you've got two carbons in the side chain, so when I mean two carbons in the side chain, I don't mean two side chains. So this and that is not two carbons in a side chain. It's two side chains with one carbon each. So that's methyl. If I had a side chain with two carbons, the side chain would have to look like this. Like it would have to be this carbon, carbon, and that entire thing there would have to be a side chain. And then we call that an ethyl side chain. If it had three carbons, it would be a propyl, so propyl side chain. But in this case here, it's methyl because there's only one carbon in it, in that case there. Okay, hope that makes sense. Another question comes through. I'm having difficulty with my reactions. Please unmute me. I have a question. Kiamakhetu, you have to put a hand up and then I can unmute you with a hand up. I can't unmute you if you don't have a hand up, right? And also, if you want to ask a question on reactions, we're going to get to reactions. We're not doing reactions right now. But if you want to ask a question on what we're doing now, please put a hand up and then we will do it. For every side chain is YL at the end of the side chain name. So methyl, yes. So if it's a side chain if it's a hydrocarbon side chain, so a side chain with carbons and hydrogens, you end it in YL, methyl, ethyl, propyl, etc. Cool. Hope I'm covered there. Let me just double check in my chat. Can you please show the question again? We'll do Tsiamo. The question says, give the IUPAC name of compound A, and then that is what compound A looks like. Hope that makes sense. Cool, thanks. Taffy posting there. Remember to follow us on our social pages there. So I meant reaction on Zoom. The feature is not giving me the option to raise my hand. Oh, Kiamogetswe. So raising a hand is not a reaction. It should be a button by itself. Let me see. Let me search for your name. See if I can allow you to unmute. Okay, there we go. Okay, you can unmute now, Kiamogetswe, if you want.
Please copy.
Yes, we can hear you. Can you hear us? You unmute again. Kiamogetswe, are you with us? Okay, Kiamogetswe, if you're struggling with that, I'm gonna mute you again, and then you can put a hand up later if you want to ask your question, just because we do have limited amount of time to finish off this lesson. So I'll give you 5
Can you
more
hear me?
seconds. I can hear you now. Yes, please go ahead.
Oh,
Kiamogetswe, you're muted again. Okay, I'm gonna move on. Just because you might be struggling. Maybe try post your question in the chat. Is it fine? Okay, I see you did post in the Q&A, right? So let me just rather do that. So in the Q&A, you said you got 3,5-dimethylhexane. So thank you for that, because I'm pretty sure there's other people who got the same answer. And I'll tell you guys why that would not be the correct one. I think Tiamo also got the same answer there, right? So the reason why you guys got 3,5 is because you numbered the wrong way. So when you guys were numbering, you numbered 1, 2, 3, 4, 5, 6. That's why you've got 3 and 5. But remember, when numbering, you always start numbering with the carbons closest to your functional group. And in this case, it's an alkane, right? You don't necessarily have a direct functional group. So you're going to pick from the carbon closest to your first side chain. So your side chain is here. That's going to be at 2. This side chain is going to be on 3. You always go for the lowest number. So 2 is always better than 3. So the numbering that you guys did was the wrong way around. That's why you got that answer. So just make sure you always number from the carbon closest to a functional group. If you can't get a carbon close to a functional group, number from a carbon that's closest to your first side chain. That's very important. Okay. I hope that makes sense to you guys. Let's jump on to the next question so we can finish. Sorry, we do have quite a bit to go. But what I will do, guys, don't panic. Whatever I can't cover and finish in this session, I will just record for you guys and I'll put it up on our YouTube and our TikTok so you can check it out there, right? Okay, great. Going back to the next question. It says 2.2.3. They want the IUPAC name of the positional isomer for compound B. So there's compound B there. Now they want the IUPAC name for the positional isomer of compound B, right? Now, it's very important that they're saying positional isomer and not positional isomers for compound B. So let's first think about how we would get the positional isomer for compound B. So for compound B, The positional isomer would be we'd have carbon, carbon, carbon. I can't move this OH to that side because that's not an isomer, right? If this OH went to the left-hand side, it's still going to just be a 1 because it's like me flipping that molecule around. So for me to have that as a positional isomer, I have to put my OH right here in the middle and put hydrogens everywhere else. So that is going to be the positional isomer for compound B. And in that case there, we had propanol as the first one there. So you can either call it someone there, Snabelo says propan 2-ol, 100%, or you can say 2-propanol as LT Shabangu did that as well. So propan 2-ol or propanol, either one of those two answers will work and will be accepted. Well done to everyone who put that down, right? So let me put the answers down there. IUPAC name for the positional isomer. So we're looking for 2-propanol or propan 2-ol. Or you can say 2-propanol or propan 2-ol. Let me quickly repeat that for you guys. So if you look at what we're dealing with there, remember an isomer, isomers are molecules that have the same molecular formula but different structural formula. And a positional isomer has the functional group in a different position. You cannot move this thing here. So you can't give me propan 3-ol or you can't give me 3-propanol. That is not the same thing because 3-propanol is actually just 1-propanol looked at from the other side. So the only isomer that you can have there is going to be 2-propanol or propan 2-ol. That's important. So you're going to have your functional group right there in the middle and not on any one of the ends. If you got that, give yourself some fire emojis, heart emojis, dancing emojis, whatever celebration. If you didn't get it, but you saw where you went wrong, join the celebrations and make sure you guys can celebrate yourselves. It's important to celebrate the wins, guys. I will continue to do this for every question because I think we spend too much time crying about the ones we don't get right and not celebrating ourselves for the ones we do get right. So let's make sure we celebrate ourselves for the ones we do get right. Cool. 2.2.4, they want the IUPAC name of compound D. So there's compound D, CH3, CH2 times 4, CH2, right? So let's draw that out for ourselves and then see how we can put it together. I'm going to just try and rewrite it down here, and then we can quickly do it together, right? So what we were given there is the following. Let me quickly put it down. Oh, don't know what happened there. Okay. So we've got this. They gave us CH3, then CH2 4 times, then CH2. So we're going to take that from our condensed structural and draw how I like to do it, my full structural formula. So CH3, 1, 2, 3, CH2 4 times, that's CH2 1, CH2 2, CH2 3, CH2 4, and then one more CH, and then CH2. And that's our double bond there. I'm going to leave the H's out for now, but then we can see that we've got that molecule that looks like this. Now they wanted us to put the IUPAC name, right? So the IUPAC name, we must first think about how many carbons do we have. So let's count our carbons. So we've got 1, 2, 3, 4, 5, 6, 7 carbons. What does that mean? 7 carbons means we're dealing with hept, right? That's 7 times our carbon. That's hept. And then we need to find the functional group. So the functional group, as we're looking at it there, we can see it's a double bond. So double bond functional group tells us we're dealing with an alkene. It's going to end in -ene, right? And then we have to figure out where the functional group is by naming our carbons. So it's on the first carbon, 1, 2, 3, 4, 5, 6, 7. So we've got one heptene or hept1-ene. One of the two will work. So if you give your final answer there, for 2.2.4, you can either write one heptene, or you can then just write hept1-ene, right? 1-ene. That's the IUPAC name of compound D. Compound D was that CH3, CH2 four times, CH2. And then if you write it out, that's what I tend to do. I struggle to take condensed structural and give you the molecular formula. I mean the name. So I always take condensed structural and then first create my full structural. Once I've got that, I can then do it step by step to get my hept1-ene. I'm going to quickly pause for questions. Right. Sorry, Lyson, this question might be from a while back and I might have missed it. I think this is from 2.2.3 asking about carboxylic acids, but that was an alcohol, but I did go through that one there. That one is fine. Okay. And then Zach says, what was the name of compound B before we made it into an isomer? So that was compound B before we made it into an isomer. That was propanol, but it would have been one propanol, or just propanol. And if you want to use that propan question mark all, that would in propan one all. Hope that's fine. There, sorry, just going through all of these questions there. Yeah, hept1-ene, Tsebo, because the double bond is between carbon 1 and carbon 2. And if you're unsure which one to use, always use the smaller one, not the bigger one. So it'll be hept1-ene. Can't I just write heptene? They used to allow it. When you look at the memo right now, it specifies one heptene or hept1-ene. They used to allow you just to write heptene, assuming that the one is automatic, right? And then someone also asked, is it incorrect if I don't write the one? When you look at the memo stipulates the one. So I'd rather play it on the safe side. Remember, when you get to your final exams, like for your everything up to your prelims, your teachers will mark. But when you get to your final exams, someone's going to mark your paper that doesn't know you, right? And someone that doesn't know you has no incentive to give you marks if they don't need to give you marks. So don't give them space to mark you down on anything. That's very, very important. So I would say let's play it on, let's err on the side of caution and then include that one in there. Awesome. Let me quickly go back to the chat. Hept1-ene, heptene, well done. So how do you know if the info or CH in the brackets is a side chain or continuation of parent chain? So that's a very good question there. Sorry, who's that? Akum, right? So Akum, if you want to know if it's a side chain or continuation of the parent chain, right? So in this case, it's a continuation of the parent chain, right? Normally, if it's a side chain, so how I know, first of all, is because here I've got CH3 followed by this. Now, the CH3 has all of its bonds taken up. So I can't necessarily have anything else beyond that. And if it's a side chain, it'll normally be given, it'll, let's say, be like this. You'll have, let me do it in a different color. What you'll get there is like CH2, CH2 in brackets, CH. And then I can then have my CH2 4. So not CH, but CH3 there. So also your side chains will be CH3 or there'll be C2H5. You won't generally have a CH2 as a side chain. CH2 normally just means all the little C's in between is just hydrogens. So that's generally how you can tell. Is just try and match the number of bonds. Akuma, I hope that helps you there. So how do you draw it out from the formula? I did that. It says it was for 2.2.2, the IUPAC name of A. Okay, Lyson, I'm not sure if I understand your question there. Tubelisa says, can you indicate the position of the double bond in this case, it being 1? The double bond, yes. So you show there one heptene or heptuanine. We did do that. Can't it be heptuanine to state where the functional group is? 100%. Reticula, yes, you can do that for sure. Awesome. Thanks, guys. Let's jump on to the next question, right? So 2.2.5 says, give the balanced equation using molecular formulae for the complete combustion of compound A, right? So using molecular formulae of compound A, oh my word, that's so terrible. Oh, no, they said molecular, not structural. I thought I had to redraw the structural formula, giving molecular formula. That's fine. That's very doable. So again, remember combustion is going to be hydrocarbon plus oxygen, giving you carbon dioxide and water, right? So to be able to do that for that question, what we need to think about there is what is compound A and the molecular formula of compound A. That's 2.2.5. Once we've got that down, we're going to then add oxygen, and then your products are going to be carbon dioxide and water. And then all we need to do is balance it at that point there. So what I want you guys to do quickly is give me the molecular formula of compound A. I'll just leave it on screen. Give me the molecular formula of compound A. Okay, if anyone has just joined us, we are busy with question, and then we're doing question 2.2.5, which says give the full chemical reaction in molecular formula of compound A. So C8H18 is correct for everyone that's put it there so far. Well done, guys. Now we need to add oxygen, end off with carbon dioxide and water, and then balance it out, right? So C8H18, that's what we're combusting. So let's quickly put that down. We've got C8H18. That's got to be mixed up with some oxygen, O2. And then we'll get carbon dioxide, CO2 plus, let me give myself a little bit of space for the balancing, CO2 plus H2O. All right. Now we got to balance our chemical reaction. I'll give you guys a chance to do that. Lita's done that already. Well done, Lita, for that. Let's give everyone else 2 minutes to try the balancing of this particular problem. When you're done, post your answers in the chat. I'm not saying Lita's right. I'm just saying as soon as you're done, post it in the chat. Okay, 30 seconds to go. Quickly try wrap up that one. Thanks, Naleti, for your answer. If you're on TikTok, you can also post your answers in the chat. If you're not following us, please follow us. We'd really appreciate that. Okay, 5, 4, 3, thanks, Gouta, 2, 1. Okay, the final balanced equation looks as follows. We need a 2 in front of the C8H18. Let me just fix that quickly. Okay, we need a 2 there. And then we need a 25 at the oxygen. And we need an 18 at the H2. 16 at the carbon dioxide. And then 18 at the H2O. If you got the answer right, give yourselves a round of applause. Any kind of reaction that celebrates your win, always celebrate the small wins, guys, no matter how small. And then if you didn't get it right, but you can see where you went wrong, also jump in there with a celebration. Awesome. Thank you for all those reactions on Zoom. Really appreciate it. Cool. Let's jump on to 2.3, all right? So 2.3 says the formula C4H8O represents two compounds that are functional isomers of each other, right? Define the term functional isomer, right? So functional isomer, let's quickly do that. Compounds with the same molecular formula, but different functional groups or homologous series. So compounds with the same molecular formula, but different functional groups. Cool. 2.3.2. The question says, write down the structural formulae of each of these two functional isomers. So we've got C4H8O, and we need to write down the structural formulae of each of these two functional groups, right? So before I put my answer down, I want you guys to tell me what two homologous series do these functional isomers belong to? That's my question to quickly post in the chat. What two homologous series do these do these isomers belong to? Quickly post them in the chat. Or if you want, you can give me the names of the two functional isomers. Thanks, Akum. Thanks, Lerato. Thanks, LT. Thanks, Nikita. Thanks, Lihle. Thanks, Ruzani, and Salailo, and Balentle, Zach. Thanks, Bonolo. And Letabo, Chauta, awesome, guys. Right, so one will be a ketone, one will be an aldehyde. Keeping in mind, the ketone has the double bond O in the middle, aldehyde has the O at the end. So we'll just draw ketone and aldehyde, both with 4 carbons, right? So we'll do the first one as C-C-C-C, and then one will have that double bond O at the end with an H everywhere else, right? So that's going to be our aldehyde molecule, and then our ketone will look similar. Let me just save the time and just copy paste this. Okay, and the difference with the ketone is that that goes away, and I have my hydrogens there, and then all I need to do is take away 2 of my hydrogens on one of the carbons. So that one, and I can replace that with a double bond O. And there's my ketone. So as long as you've got any 2 of those there, then you are winning. The double bond O can literally be on this side, it can be here, it can be here, any one of those 4 positions, and you're winning, right? So it doesn't have to be specifically on this carbon. It can be on this carbon, but up top. It can be on the next carbon up here. It can be down here. Anywhere of these 4 spots, the answer will still be correct. Awesome. Hope that makes sense. Just to double check that everyone is still with me, just give me a thumbs up in the chat, and then I'm going to pause quickly for questions. Okay. Zach says, so when balancing, what should we use to balance or try to get the same first? And then, so let me quickly go back. Sorry, I missed those questions there, right? So generally when I'm balancing, what I try and do is I look at what exists by itself, right? Whatever exists by itself, I leave that for last because it's the easiest to balance without having to affect other things. So when looking at this particular problem here, my oxygen is by itself. So that's the last thing I'm going to balance. So I'm probably going to start off with my carbons and my hydrogens, and then work my way to oxygen as a final thing there, right? That's generally how I would do it there. So on my side, if you look at the process of how you go about balancing this, let's say I decided to start with my carbons. I would have then said, well, 8 carbons here, 1 carbon there. I would have first put an 8 um, through here. Then it changes my oxygens, but I'll come back and sort the oxygens out later. Then I would have said, okay, hydrogen, I've got 18, I've got 2 there. I would have put a 9. But then when I try to balance my oxygens, what I would find is that um, I've got 2 and 1, which is an odd number of oxygens. So I need to double the number of oxygens across just to be able to balance that correctly. So then I would change this and double this from 9 to 18, right? Which would force me to come back and change this from a 1 to a 2. All right, and then I'll do that, and that's going to then also change my 8 to a 16. And then once I've done that, all I've got to do is fix my oxygens, and then I can just see that I've got 50 oxygens on the right-hand side, and then I come back on the left-hand side and put my 25. I hope that answers your question, Zach. Then we've got Nyaleti there. For the combustion reactions, does it matter if I'm given an odd or even number of carbons? If it does, how does it differ? So it really doesn't matter. All you're going to do is it's a matter of balancing, whether it's an odd or even number. Your balancing should fix everything else out. So even if you had C3H8, it'll still work out when you're balancing everything else out. Cool. Hope that helps, Nelity. Awesome. Let's jump on to the next question, and we're going to do a little bit of stoichiometry with our organic chemistry, but I know you guys can do it, right? Okay, so 2.3, the formula C4H8O, sorry, that's the wrong question. Sorry, 2.4 is our last question for this one here. A 2-gram sample of compound E contains 1,09 grams of carbon and 0,18 grams of hydrogen. The molecular mass of compound E is 88 grams per mole. Determine the molecular formula of compound E by means of a calculation, right? Okay, so now we have to do a little bit of stoichiometry, but like I said, man, I believe in you guys. I know you guys can definitely do this thing. So let's quickly have a look at how we would solve this problem. So let's see. So the total mass is 2 grams. And then compound E, let's quickly go back. Compound E is that CXHYOZ, right? Let's quickly put the name of compound E. C X H Y O Z, right? And we're told that carbon, we've got 1,09 grams, and hydrogen, we've got 0,18 grams. And then oxygen, we can just do the maths, right? If we've got 2 grams in total, that's going to be 2 grams minus 1,09 plus 0,18. So if you put that together, you can pretty much figure out that we've got 0,73 grams of oxygen in that sample. Hope that makes sense to everyone. Siamo said 0,73. Well done, right? We've got that there. Now, they want us, so we also know that the molecular mass for the entire compound, right? Relative molecular mass is 88 grams per mole. Now, they want us to determine the molecular formula for compound E by means of a calculation. All right, cool. So we need to try and start by working out an empirical formula, right? So the empirical formula will be our simplest ratio of everything that we're dealing with. Once we've got our empirical ratio, empirical formula, we can work our way towards a molecular formula, right? So let's first try and find the empirical formula for it. To find the empirical formula, we need to go and work out the simplest ratio of the moles of carbon, hydrogen, and oxygen, which means first converting the grams of everything to moles. And we do that through the formula N is equal to mass in grams divided by my relative molecular mass, right? So for carbon, we're going to have number of moles of 1,09 divided by relative molecular mass for carbon is 12, right? If you plug that into your calculator, you should get an answer similar to 0,0908. And then for hydrogen, we've got 0,18 grams. That looks like a 6, apologies. 18 grams. And the relative molecular mass for hydrogen is 1, which means the number of moles of hydrogen in that sample is 0.18. And then finally, oxygen, right? For oxygen, we have 0.73 grams. And the relative molecular mass for oxygen is 16. So we have that divided by 16 should give you 0.046 grams per mole, right? Or moles rather, so not grams per mole, but actual moles. Now, when doing empirical formula, the next step is we need to figure out the simplest ratio. So we're going to divide everything by the smallest number we've got there, right? So the smallest number we've got there is going to be 0.46. This is our smallest number, right? So if we then go and say 0.046 divided by 0.046, we're going to end up, so again, here we divide everything by 0.046. So in this case here, we'll see that we have 0.046 divided by 0.046, and that should give you one simple clean, right? 0.18 divided by 0.046 should roughly give you a number close to 4. And then we've got 0.0908 divided by 0.046 should give you a number roughly close to 2. And then we can see our empirical ratio is going to be 2, 4, and 1. So when we put that together, let's quickly write down. So we're going to have C2H4O1. But let's first work out the relative molecular mass of that, right? So if I want to work out the relative molecular mass of that, of C2H4O, you'll find that I've got 2 carbons, so it's going to be 2 times 12 plus 4 times 16, 4 times 1 plus 1 oxygen, right? And that will give me 12 times 2 is 24. Sorry, not plus 1, that's 16. 12 times 2 is 24, plus 4 is 28, plus 16 is going to give me 44. So that's 44 grams per mole. But that's for my empirical molecular mass. We were told already that the relative molecular mass for compound E is 88 grams per mole, right? So what we know is that the actual molecule is twice as heavy, right? So because it's twice as heavy, to get the final thing, right, the number to multiply by, we divide, so we'll just call it our N. We say 88 grams per mole divided by 44 grams per mole equals 2, meaning my final molecule actually needs to be C4H8O2. Okay. A lot of you guys got the answer right already. Well done to you guys there. But then I hope you guys followed me. If you were unsure, I'm going to quickly pause for questions there. So how do you write the structural formula using the balanced equation, right? So the structural formula, you just draw it out essentially, but we will ask for the molecular formula. I hope that makes sense there. If it doesn't make sense, please put a hand up and then you can ask your question more clearly in person. So where do you get the 2 in the oxygen part of the compound while dealing with the mass? I'm just trying to see exactly. Oh, okay, cool. I'm with you. I think I know what you're talking about, right? You're talking about this part of my calculation. So remember, we were told that a 2-gram sample of compound E. So this compound is 2 grams. 1.09 grams is carbon, 0.18 grams is hydrogen. So we need to try and work out what is the rest. So the entire thing is 2. So I'm going to minus my carbon and minus my hydrogen from this total, and that will give me my oxygen. Cool. Hope that makes sense to you there. Lisa says, sir, can you repeat on how you got the grams of oxygen? I just did that now. So I hope that makes sense to you, Lisa. And Zebo says, sir, I don't understand how you got 0.73 grams of oxygen. Zebo, I hope that makes sense to you guys now. Zebo, Litlen, Letu, please just confirm that you guys are with me right now on that particular one. And then Giamocheto says, please repeat how you got to the molecular formula. Okay, I'll do that. So let me quickly from the beginning explain what the thought process is. So we're given 2 gram sample, we've got 1.09 grams of one, 0.18 grams of another one, and we're going to find the grams of the other. That's the easy part. To get the molecular formula, we need to first figure out what the empirical formula is. So that's the process by which we then work out the number of moles of each, right? So we then took the grams divided by the relative molecular mass. So I did that for carbon with that. I did that for hydrogen with that. I did it for oxygen with that 0.73. Now I've got the number of moles of carbon, hydrogen, and oxygen in my sample. To find the simplest ratio of them all, I will divide by the smallest number that I've got here, that small number being 0.046. So dividing by that will give me a ratio of 1 is to 4 is to 2. And that ratio gives me the ratio of my empirical formula for that particular compound E, right? My empirical formula is C2H4O1. But I know my molecular formula, my molecular mass is 88 grams per mole. I want to figure out what is the mass, the molecular mass for my empirical formula. And then that's what I did there to find that my molecular mass for the empirical formula, or the empirical mass, if you want to call it that, is 44 grams per mole. The real thing is twice as heavy, which means it must contain twice as many molecules. So that means when I do this calculation to see how different is my molecular formula from my empirical formula, and it's going to be a factor of 2. So what I do there is I multiply this number by 2, that number by 2, that number by 2. And then I get C4H8O2, and this is my molecular formula. Okay, hope that makes sense. There's a couple more questions that I'm going to answer. Quickly try and scroll down to them. So please repeat on how you get the molecular formula. I just did that. How do you know the compound is oxygen? Well, remember, they said compound E, and compound E is the CXHYOZ. So the compound isn't oxygen, but the compound has oxygen. Oh, that you did fix your question, sorry. I was told CXHYOZ. That's what is part of my compound. And then I even came back and I wrote it down here as well because you were given that as your compound. Cool. Awesome. Hope that makes sense, guys. I did take a lot longer with this question than I would have liked, but it's not a train smash because it means I had a lot of questions and there was a lot of clarifying that I had to do, which I think is critical and I think is very important, right? We do still have 2 parts of organic chemistry to go through, which is organic reactions as well as organic physical properties, boiling points, etc. We only, though, have 8 minutes left of this session. So here's what I'm thinking. I'm thinking we're gonna just do a general Q&A for the last 5 minutes on what we've done now. And I'm gonna arrange with the team to add another session for us to do organic chemistry, just part 2, right? Because I think I can do the recordings, but it doesn't give you guys a chance to ask questions. And I think you guys ask really good questions. So I'm gonna arrange with the team to add another session. We are full for this week in terms of sessions, so it'll have to be sometime next week. It'll probably be next week, Tuesday, same time, that we will finish off organic chemistry, the last 2 sections. Are you guys happy with that? Nikita, note your question, but I'll come back. So just post in the chat if you guys are happy with me to say, I can do a recording, but I'd rather do a live session again with you guys. So we'll do next week, Tuesday, this time, and then the team will just update that. Okay, lots of yeses. So I'm happy with that. Okay. That was helpful. Awesome, awesome, awesome. Thank you guys so much. Please, what I would appreciate as well, give me in a nutshell before we do the Q&A, how has this session been? How was it useful? What do you want me to do more of? What do you want me to do less of? How can I make the sessions better for you guys? Quickly post that in the chat. I would really appreciate it. Okay. Someone says, can't you replace one of the sessions and move them to next week? Siamo, we've already set the structure for the week, and you guys, it's during holidays, so I think you guys should be fine. But we'll have a look with the team in terms of what we can do in that case there. Maybe we move tomorrow's session to next week and we finish off organic chemistry tomorrow. I'll have a chat with the team and see how we can do it. The key thing is make sure you guys join all the sessions. That we would really appreciate that. Okay, cool. Thank you guys for your feedback. If you guys feel like we gave you 5-star service, right? I would really appreciate a Google review. So we'll post a link in the chat now. If you feel like we gave you 5-star service, I'd appreciate a Google review. Please, the 5 stars are great, but what's more useful is telling people what you enjoyed about the session. So just specify, I liked the presenter, I liked how he explained, or I liked, how they simplified the concepts. I liked the notes. Just specify what you really liked about it. So we're gonna put a link in the chat. Give me 2 seconds to put it down now. And then with that link, please leave us a Google review. We really would appreciate it. It helps us quite a lot in being able to do sessions like this for you guys, right? So I will, Taffy, if you've got that Google review link, please can you post it in the chat? Then I can attend to more questions, right? Okay. I think I'm actually close enough to actually getting that link. Give me 2 seconds. Awesome. And when you leave the Google review link, guys, what I would appreciate is to say, I joined a webinar winter camp, learning space winter camp, and this is what I liked about the session. I'm pasting the link in the chat right now. Okay, so there's the link in the chat. Click there. If you feel like we gave you 5-star service, please go leave us a 5-star review on Google and write down what you liked about the session. Really appreciate that. Awesome. Let's quickly come back to the last questions you guys might have. The WhatsApp link. Taffy, do you have the link to that WhatsApp community?
Yeah, I will post that.
Awesome. Thank you so much, Taffy. Okay, awesome. Guys, we've got 3 minutes left. Any last questions? The WhatsApp community link is coming. So can you please do an applications of organic chemistry next time? Koketo, please, yeah, give me a little bit more on the applications of organic chemistry. So maybe we'll touch that more on the reactions, because that's more where you really get applications. For now, this was really helping us understand the nomenclature, the naming, the drawing, because once you get that right, the next sections become a lot easier. But we needed to really bed this stuff down well. Once we've bed this stuff down well, we're going to jump onto the next one, and then we'll be able to do it well there. Awesome. Taffy's posted that link. I'll wait for any more questions. And if you'd like to ask your question live, please put a hand up and then I'll allow you to unmute. Okay, I'll give you guys a minute or so. The mass of empirical formula, how did you calculate it? 100%, I'll do just that for you. Who was that? That was Oluetu. So Oluetu, if you come back, so once we have the empirical formula, C2H4O, calculating the mass then becomes pretty chilled, right? Because what we need to do there is say, well, I've got 2 carbons, 4 hydrogens, and 1 oxygen. So 2 carbons, carbon has got a molecular mass of 12. And then I've got 4 hydrogens. Hydrogen's got a molecular mass of 1. So if I can just put like brackets around this, that's for my hydrogen, and 1 oxygen, which has got a molecular mass of 16. And then I just put that together, 2 times 12 plus 4 times 1 plus 16, which will give you 44 grams per mole. And then to get to your molecular formula, you then do the comparison of 88 divided by 44, which will give me a factor of 2. From there, I know to double everything from my empirical formula. 2 becomes 4, 4 becomes 8, 1 becomes 2. There's our molecular formula in that case there. Hope that makes sense already too. Recipient says, what's the name of the YouTube channel? It's called The Learning Space ZA. I'll also post a link to that in the thing. So you guys can please go subscribe. help us grow. All a lot of our lesson recordings from before will be there. So if there's other topics we haven't touched on, you guys will find them there as well. And normally it takes about 48 hours to cut this up and post it up, and then you'll find this lesson as well on YouTube. I'll quickly put the link to that as well. Give me 2 seconds to quickly find it. I think if you scroll up somewhere in the chat, I think Tefi posted a link to all of our socials. Okay, I'm just quickly getting this. Okay. That's a link to our YouTube, and I'll also give you guys a link to our TikTok. Give me 2 seconds. Tef, if you can find the link to our IG while I do this, that would be epic. And then Instagram. Okay. And someone asked there, recipient says, on the WhatsApp community group, does this send the links to the classes there as well? We don't, but if you've already registered and you're here, we'll SMS you guys the links to the classes once you're already registered here. But I will also I'll remind the team, I'll ask Theo to share the links in the WhatsApp community as well. Unable to open the link to the WhatsApp community, please help. I'll try and see how I can help you with that one. Cool. And then Nikita says, when drawing an ester structural formula, do you have to draw the alcohol section, example, the ethyl, first, or is it just for naming it in words? And when doing the condensed structural formula for the ester product, do you start with the carboxylic acid? So for the structural formula for esters, you don't have to draw it any which way. You can draw carboxylic acid side first or the other side first. And I think even for condensed structural, it doesn't really make a difference. As long as when you put it all out, it still makes sense. So whether you do the ethyl or the anoate side first, it doesn't make a difference, Nikita. Hope that helps you. Okay, and then last one, just we are out of time. Dondani says, I didn't understand 2.3.3. Let me see. Dondani, we did not have a 2.3.3. So yeah, maybe just watch the recording, Dondani, and then that should help you. And then Oluches, the notes, please. I'm gonna post those. As soon as I'm done, I'm gonna just export these to PDF and post them in the WhatsApp community. Those will be up today, and then the recording of the lesson, give us 48 hours. It should be up in 48 hours. Cool. Awesome, guys. Thank you guys so very much. I really do appreciate the time you guys spend with us.